Turn it on. Turn on the microphone. Test, 1, 2. Now you can hear me? Wow. So the first thing you're going to do is identify if it's linear or quadratic or something else. Okay. This equation right here is quadratic. Can somebody raise their hand and tell me how I know that? Brandon. It has a squared variable. That tells me right away that it's going to be a parabola. Quadratic in nature. Okay, so we can also write that down here as part of the function, describing the function. It's quadratic. Can somebody tell me which way it's going to open? Raise hands. Yep. Okay. How do you know it's going to open up? What is this?
Oh, it's going to reflect across X.
Yes. So which way is it going to open? Down. Thank you, Jacob. Okay, because the A value is negative. So that means it's going to face upside down. So technically my graph should look upside down like this. Not this. Any questions? Okay, so this is y equals a times x minus h, the whole thing squared, plus k. So we need our vertex. Ruby, what's the vertex here? Are there any parentheses here? So that would be a 0. And then what would the 5? Any questions over that? Since there's no parentheses, there's nothing being added there, so that's a 0, 5. So we're going to graph that. We're going to go where x is 0 and y is 5. Oh, this graph is going to be interesting because I have to go up here. And we switch those graphs too. Any questions over that? Then we need our A value. Sydney, what's the A value? -1. Okay? So our pattern rate of change is A over 1, then 3A over 1, then 5A over 1. So since A is -1, it's -1 over 1, then 3 times -1 over 1, then 5, sorry guys, over 1. So from here, I'm going to go down 1 over 1, down 1 over 1. Then I'm going to go down 1, 2, 3, and over 1. Then down 1, 2, 3, and over 1. I'm going to go down 5, 1, 2, 3, 4, 5, and over 1. Down 1, 2, 3, 4, 5, and over 1. And this is my beautiful parabola. Any questions on that? Okay, let's now talk about, is this a function or not a function, class? Oh, we weren't too sure about that. Who thinks it's a function? Okay. Who thinks it's not a function? Okay. Functions pass the vertical line test. So let's take our vertical line, go across the graph. Does it ever touch in more than one spot? No, it does not. Okay, so this is what we call a function. If the quadratic that opens up, it is a function.
Why is it blinking like that?
And it just decides, sometimes it does, sometimes it doesn't. Okay. Now the new thing we're going to talk about is the intervals in which it increases and the intervals in which it decreases. Okay? Increasing is, as the x gets bigger, what are my y values doing? As my x goes this way, what are my y values doing? They're going up, right? So you always look at it from the x perspective. Okay? As x goes this way, my y values are increasing. Okay. It's increasing from this point here, which is going down forever. So it's increasing from negative infinity to... At what point does it stop increasing? Okay. At 0, 5, it stops increasing. What is the x value there? 0. So it stops increasing at 0. Now it's going to be a little different. You do not need a bracket here. Okay? Because at 0, it's neither increasing or decreasing. It's changing directions at that point. Okay, so it will not be increasing at 0. It's kind of changing directions, basically. Okay, it'll be a point of inflection. You'll learn that in pre-cal or integrated 3 probably, maybe even now. Okay. But you need to know it's not going to be this. Because it's not increasing at 0. Any questions over that? Okay, then the second part of the graph, so from 0 to positive infinity, what are my y values doing? They're decreasing. So then we're going to say decreasing. From my point of inflection to positive infinity. Any questions over that? Okay, then we're talking about the domain. So the domain are all my x values, okay, going from left to right. Since my parabola gets wider forever and ever and ever, okay, there's no limit to how far left or limit to how far right it can go. The domain is negative infinity to positive infinity with parentheses because it cannot equal. Or we could say all real numbers. Any questions over that? Yes.
So domain is left to right.
Domain is left to right. Range is up and down. So you put that. X, domain is X, or left to right. The range, though, does have a limit. If we look back at the graph, what's the highest my graph can go for the range for the y values? At 5. Okay? Does it have a limit as to how low it could go? No, go on forever. So the range is 5 is the high, oh, not 5. Sorry. We always start with negative infinity, with negative numbers or smaller numbers, to 5. It cannot equal negative infinity. It can equal 5, because that 5 is the highest it can go. Okay, then we need to talk about another way to write this. We could also write this, or range is y, could be less than or equal to 5. Any number that's less than or equal to 5. You could write this either way. This is interval notation, and this is inequality notation. And you'll see them both from now on. Any questions over that? We're all good? Okay, now we're going to do the inverse of that same function. Okay. So we have the equation. Over here, we're just going to replace the x and y, and then solve. So x equals negative y squared plus 5. And then solve. So I'm going to subtract 5 from both sides. I'm going to get x minus 5 equals negative y squared. Then I'm going to divide by negative 1, divide by negative 1, divide by negative 1. And I get negative x plus 5 equals y squared. Now I can square root both sides. And I'm going to get y equals plus or minus the square root of negative x plus 5. Any questions over that? Okay, when you divide a negative divided by a negative becomes positive. Yes. When we think about it in our head, when we look at it, oh, it should be a minus. But you forget that this has a negative in front. If your a value is negative, it's going to throw it all off. Okay. So now, we have not learned how to graph a square root, and you will not learn how to graph a square root until next year. Okay. So we're just going to take our ordered pairs and switch the x and y. So I'm going to use those ordered pairs from this graph. So this ordered pair was 0, 5. So over here we're going to graph 5, 0. So I'm going to go where x is 5 and y is 0, which is right here, and graph it. Any questions over that? Okay, then I'm going to take my next one. This point right here is where x is 1 and y is 4. So I'm going to graph where x is 4 and y is 1. This is 5, 0. Then I'm going to graph this other point, which is negative 1 and 4. So I'm going to go where x is 4 and y is negative 1. So I'll do the next point, 2 and 1. So I'm going to graph where x is 1 and y is 2. And that right here as well. X is 1, y is negative 2. Because that'll be this point here. So this is now my parabola turned on its side. Any questions over that? We're all good? Okay. Now I need to describe the function. This too is quadratic. Which way does it open? It opens to left. Okay, it opens to the left. Is it a function? No, this is not a function. Because if I took my vertical line and I went across my graph, notice here it would cross at 2 points, here it would cross at 2 points, okay? And that's not okay, so it's not a function. Any questions over that? We're all good? Okay, next thing. Increasing and decreasing. This is not a function, so we're not really going to talk about increasing and decreasing because your graph is actually increasing and decreasing at the same time. Okay? So you don't need to talk about that. You only want to talk about how it's changing. If it's changing. Okay, and since this is doing both at the same time, it's not something we really talk about. Okay? Any questions over that? Okay. We can do the domain and the range now. The domain is the x values again. And the domain of the inverse function should be what the range was of your original function. So let's check it. Okay. The domain is going to start at 5 and only get smaller. So the domain is going to be negative infinity to 5. Can it equal 5? Yeah, I have a closed circle there. It can equal 5. Or I could write it as x is less than or equal to 5. Any questions over that? Okay, the range is the y values. And the y values are just going to keep getting bigger and keep getting smaller forever. Okay. So the range here is going to be negative infinity to positive infinity, or all real numbers. Any questions over that? We're good? Okay, next example. Okay, so 2x minus 4. Let's start with linear or quadratic. Dustin, what is that? Linear. And how do you know it's linear?
Because it's now set square.
There's no squared variable, so it's going to form a line. Okay, so that's when we're working with y equals mx plus b. So you want to identify the slope, identify the y-intercept. Frank, what's the slope and the y-intercept? The slope and the y-intercept of this equation. -4, very good. Okay, so we're going to begin at -4 on the y-axis. And I'm going to go up 2, 1, 2, and over 1. Go up 2 and over 1. Go up 2 and over 1. And so this is my graph, I think. Okay, so we've already talked about this being linear. Is this a function? Yes, it's a function. Is this line increasing or is this line decreasing? Increasing. All the time or some of the time? All the time. As x gets bigger, y is constantly getting bigger. Okay, this is increasing. You can also just look at the slope. If the slope is positive, it's increasing. Slope's negative, it's decreasing. Okay? So you would write this as increasing from -infinity to positive infinity. Any questions over that? Your domain. Sarah, what's the domain here? How far left and how far right? That's a slope. It stops at 1. It doesn't go to 0 for x, or -1 for x, or -2. It goes forever, right? That's the arrow means forever. So it's infinity. So -infinity, where does it stop? Going this way. Infinity, at positive infinity. Domain for all linear equations goes on forever and ever. Okay? Now the range. Range is up and down. Evan, what is the range here? Very good. It's going to go forever up and forever down. So -infinity to positive infinity. Any questions over that? We're all good? Okay. Next one. Okay, so now the inverse, we're going to take that original equation. We're going to replace the x and the y. Okay, everyone solve that for me. Find the inverse for me. Okay, add 4 to both sides, right?
And then you get, x equals 4 equals 2y. Then after that, you're gonna do the, divide 2 on this side.
Yes. Okay, a lot of you got stuck here. Okay, because we actually want to graph this, we want to divide this out. Okay, so I'm going to get y equals, x divided by 2 is just going to stay x over 2. Then you also divide 4 by 2. 4 divided by 2 is 2. Any questions over that? Okay, then we're going to find the slope and the y-intercept. Allie, what's the slope and the y-intercept? What's the number on top? So it's 1 over 2. And what's the y-intercept? 2. So we're going to get at 2 on the y-axis, and then go up 1 and over 2. Up 1 and over 2. Down 1, and left 2. Down 1, left 2. And then this is my equation of my line. Any questions over that? We're good? Okay, we're going to describe that function again. It still is linear. Is it a function still? Yes, function. Is it increasing? Yes. Always? So increasing from negative infinity to positive infinity. Okay. Domain and range, same thing. Okay, it's going to go on forever left and right. So from negative infinity to positive infinity, or all real numbers. However you want to say it. Same with the range, it's going to be from negative infinity to positive infinity, or all real numbers. Any questions over that? We're all good? Okay. On the back. Okay, before we do any of the equation, let's start by you guys just describing the function, giving me the domain and range. You guys work together on that, okay? Okay, so this point here is 3 for x and negative 3 for y. That is your vertex, 3 and negative 3. The a value should be up 2 and over 1, so your a value is 2. You're just going to plug it right into the a times x minus h squared plus k. This is h, this is k. So your equation is going to be f of x equals 2 times x minus 3 squared minus 3. Okay, most of you described the function and said it was quadratic. It is a function. You even write down increasing and decreasing, so let's discuss where this is increasing and where this is decreasing. Okay? So as I'm coming this way, as x is more negative, what is my y values doing? It's going down. Okay? So it's decreasing. From, again, my x value, negative infinity, to what is my x value, where it stops decreasing? 3. A lot of you put the y value. Again, this is talking about, from the x perspective, what is the y doing? The y is decreasing as x is negative infinity to positive 3. At 3, it's making that change. Okay. So then it is increasing from 3 to positive infinity, the second part of the graph. Any questions on how I got that? Yes. Because at 3, it is not increasing or decreasing. It's changing directions. Okay? It's not talking about being equal to 3. It's saying what is it doing at 3. And at 3, it's neither decreasing or increasing. At 3, that's called our point of inflection, and it's changing direction. Any questions over that? Okay, the domain of this function, again, parabolas can get wide forever. Okay, they will go forever wide. The domain for a parabola facing up or down will be negative infinity to positive infinity. The range is going to be different because it has an end or a starting point and it goes on forever in one direction. Okay. So what's the lowest this graph will go? Negative 3. What is the highest it will go? Infinity to positive infinity. Oh, and what I do wrong? Can someone tell me what I did wrong there? No bracket. I can equal negative 3 here. I know, I was very excited about that. Bracket. Okay, remember this can be all real numbers. And this could also be x is greater than or equal to negative 3. Any questions over that? Okay, now let's talk about the inverse. The equation of the inverse, we have to take this equation, replace the x and the y. And then solve. So I'm going to add 3 to both sides. I'm going to get x plus 3 equals 2 times y minus 3, the whole thing squared. We're going to divide by 2. We're going to divide by 2. We're going to get x plus 3 all over 2 equals y minus 3 squared. Now what? Square root. Let's square root. Let's square root. Okay, so then I'm going to get plus or minus the square root, x plus 3 all over 2 equals y minus 3. Then I would add 3 to both sides. And I'm going to get y equals plus or minus the square root of x plus 3 all over 2, and then plus 3 on the outside. Right. But, no, now it's decided to.
Is it a projector, is it like a computer, or?
Either ran in the ceiling or across. Yeah. Okay, let's keep going. So now, describe the function. Oh, let's graph this now. Okay, this doesn't help me graph it. This is going to help me graph it. So let's graph those ordered pairs. So 3 and negative 3. So now I'm going to graph negative 3, 3. Negative 3 and 3. Then I'm going to graph this point here, which is 4 and negative 1. So I'm going to graph negative 1 and 4. Then I'm going to graph 2 and negative 1. So now I'm going to graph negative 1 and 2. And we're just going to leave it like that and graph those points as a parabola. Any questions over that? Okay, so once again, describing it, quadratic. It is increasing, is the function decreasing from? Okay, is it a function? Not a function, nope. Okay, and again, because it's permanent side, we won't talk about increasing over certain intervals or decreasing, because it's doing both at the same time. Okay. Domain. Again, our domain and range should just switch places. So our domain should be negative 3 to positive infinity, or x is greater than or equal to negative 3. Let's just check it, though. So here's my domain for the x values. The x is negative 3. And does it just get bigger? Yes, so that domain does fit. Okay? And then the range then should become the domain of the previous original function, and, or all real numbers. Because it's negative to positive infinities, and that's every number in the world, right? Yes.
When you're describing it, you have to like it.
Not this one. Not when it's turned on its side. Okay. Any other questions? Oh, we should talk about it opening one direction or the other. What way does this one open? Open right. And this is opening up. Okay. We didn't already talk about that. Any questions? Next one. Okay. Okay, do this one on your own.
Oh, wait.
Our equation, our graph, should be, oh, this is -1. -4, -1, -2, wait, -4, -2, and 0? Oh my goodness. Okay, I don't know why I did that. And then 0, and 2, and then,
You're doing it wrong.
I know I'm doing it wrong. I'm so confused myself right now. -4, -1. There we go. -2, 0. Whew. Then 0 for x and 1 for y, then 2 and 2, then 4 and 3. Okay. Yay, I got it. And I missed it. Your equation should be y equals 1/2 x plus 1. Most of you have that. I think I got through everyone to see that. It is linear. It is a function. And it's increasing forever. From -infinity to positive infinity. Any questions over that? Okay, the domain is -infinity to positive infinity, because it's forever going left and right. It's forever going up and down, so it's -infinity to positive infinity as well. Okay, you can find the equation of this 2 different ways. You can graph the ordered pairs and then find the slope and the y-intercept, or you can solve for, switch the x and y and solve. Either way will work. You'll get the same answer. Probably the easier way is just to graph the points. So I should graph -1, 0, 1, 2, 3, and then -4, -2, 0, 2, and 4. So I'm going to go where x is -1 and y is -4. I'm going to go where x is 0 and y is -2, 0, and 1. 1 and 0, and then 2 and 2, and then 3 and 4. And that'll be my line. Any questions over that? Okay, domain and range should be the same thing. The equation should be y equals, my slope is 2, and I'm crossing the y-axis at -2, so 2x minus 2. Any questions over that? We're good? Okay, your homework is the next 3 pages. There are 6 problems that you have to do for homework. Next 3 pages, there are 6 problems.
Wait, the next front and back like this, and this.
So,
Front and back of each page?
6 problems. So 1, 2, 3, 4, 5, 6.
Oh, I thought you meant 1 page, 2 page.
Okay, so I didn't get a chance to come around and stamp anybody, or how to recommend anything. So hold on to those for me, and I will remind me to do that on Tuesday. Okay? Not now. Wait until it's in the computer, because I'm not going to remember. Yes.